Hello, so welcome to this week's weekly board practice solution. So this problem is a transmission line problem from 1001 solved problems in electrical engineering. The problem is a short three-phase transmission line has a resistance of 3 ohms and an inductive reactance of 4 ohms. At the receiving end, the voltage is 13,250 volts line to line with the load which does 200 amperes at 0.707 lagging power factor and the capacitor bank drawing 96 amperes. To solve for the power factor at the sending end. The correct answer here is 0.935 lagging. So at the end of the solution, we shall get this answer. Okay, so this is the short transmission line model or the equivalent circuit of a short transmission line. So kung mapapansin nyo, it starts with the generator side. So the voltage generated with the generator is the Vs, or that's the sending voltage. And the current from the generator is Is. So that is sending current. Kaya ang tawag sa side na to, sa generator side, is sending end. Ngayon, yung transmission line natin, connected siya sa generator. Okay? So, ayun yung transmission line natin is yung transmission line natin. So, meron tayong parameters sa transmission line. We have the resistance R, RL na lang na, RL, and the inductive reactance XL. Okay? So, yung dalawang yan, pag in-add, so that's the impedance of the line. Okay, sa load side naman, we have the VR, or that's the voltage across the load. That's the receiving voltage, the VR. Pwede ng VL, pero sa book kasi ginagamit VR. And then we have IR, and it's the receiving current. So kaya ang tawag sa side dito sa ang tawag sa load side, that's the receiving end. Ngayon, kung gagawa tayo ng equation dito via KVL. So by KVL, so we have VS minus ISRL minus ISXL minus VR is equal to 0. Ngayon, i-arrange natin. So, may iwan sa left side yung VS and then the rest of the parameters are at the right side. So, and then, i-factor out natin yung IS. So, VS is equal to VR. So, inuna ko lang yung VR. No? Ito. Plus IS RL plus XL. So, yan. Yun yung ating equation na gagamitin for short transmission line problem. So, meron tayong mga note lang. Yung gusto ko sabihin ng mga note. So, ang approach natin dito is vectorial. Meaning, yung BS, BR, IS, RL, XL, vector quantities yan. Hindi siya, so vector quantities, so may associated magnitude and direction to. Okay? Because we are dealing with AC, no? AC circuit to eh. And ano pa? Per phase basis lagi ang atake natin sa mga problems. So, kung single phase to, so walang problema. Ngayon, kung three phase to, edi per phase basis pa ang gagawin. Okay? Next is, we have assumption na ang three phase system natin is Y connected unless stated na delta connected siya. Okay? So, yun lang. Balik tayo sa problem. So, for the solution, first, gawin muna natin yung diagram para mas madali yung pag-solve natin. So, gawin natin yung generator. So, so the resistance, the inductance, the inductive reactance pala. So, we have the load. Okay. May dalawang kasing load tayo dito, yung 200 amperes at 0.07 lagging power factor. And the capacitor bank drawing 96 amperes. So, nakakonect yung capacitor natin in parallel. Okay, with the load. Maybe for the purpose of power factor correction. Okay? Bigyan natin yung mga parameters natin. So, ito yung VS, sending voltage. And then, we have the IS. So, ito yung RL. Ito yung XL. So, ito yung VR. Ito yung IS. Wait. Ano? IL to. Load. Load current. Load current. And then, capacitor current. IC. Wait then, sulat natin yung mga given. Wala naman tayong given na VS tsaka IS. So, let's start with the R. RL is 3 ohms. XL is 4 ohms. And then VR is 13,250 volts line to line. And iba, IL 200 amps at 0.707 power factor lagging. And the IC of 96 amps. Okay, so meron pa ba? Wala na. So, ang pinapahanap dito is power factor at the sending end. Okay? So, paano pa tayo kumuha ng power factor? The power factor is just the cosine of the angle. No? Kung ano man yung hinahanap. No? So, in this case, power factor at the sending end. So, that's the cosine of the theta at sending end. So, that's the angle between the sending voltage and the sending current. Okay. So, yun yung ating equation 1, no? Yung pinaka-equation natin. Okay. So, the problem is we do not have VS and IS. Pero mas-solve naman natin yan. So, let's start with the IS. So, by KCL. So, makikita nyo, pwede tayo mag-KCL at this node, di ba? Sige, let's say this is junction X or node X. So, by KCL at node X, we have IS is equal to IL plus IC. Okay. Since itong mga quantities ito ay vectors, so may associated direction siya. Drawing muna tayo ng vector diagram. So, ayan siya. So, dito sa problem na to kasi mas madali natin may isolve if we will assume that the receiving voltage is at the reference. So, assuming VR as the reference phasor natin is the reference. So, kung VR ay nasa reference, ibig sabihin nandito siya sa positive x-axis. And VR. Okay. So, pwede na tayo proceed sa KCL ulit. So, IS is IL of 200. Ano yung direction niya? So, 0.707 laging power factor siya. So, para makuha natin yung angle, we just have to get the R cosine of 0.707. So, that is R cosine of 0.707. That's 45 degrees. Since laging power factor siya, so laging, so negative ka. Plus yung IC natin is 96 amperes. So anong angle niya? Siyempre 90 degrees, diba? Positive 90. So IS is now what? IS is 200 angle negative 45 plus 96 bar 90. 148.54, 𝐤𝐴L, negative 17.81. Oops. 154 point, ano yun? So, bar 𝐤𝐴L, negative 17.81 degree amperes turn. So, ano ulit siya? ₱54. 154.54. Ano ba? 148.54 pala. Ay, ayaw magbura. Ayaw niya magbura, no? Gumana ng eraser. Bakit? Anyway, sige. Isa na natin siya. So we have IS is 148.54, 𝐤𝐴L, negative 17.81 degrees ampere. Okay? So, solve na natin yung VS. So, VS is, di ba may equation tayo kanina? So, VS is equal to VR plus IS, quantity RL plus XL. Gawin natin siya dito. So, VS is VR plus IS R plus XL. VS, so, ang VR natin is what? 13,250 volts line to line. Yun nga, sabi ko, per phase basis tayo. And we assume that this system is Y connected. So, ang kanyang per phase value, yung phase voltage niya is 13,250 over square root of 3. So, dahil nasa reference natin ng VR, so ang kanyang angle ay 0 degrees. So, plus 148.54 angle negative 17.81 degrees times R of 3 plus J4. So, bakit may J? Kasi inductive reactance siya. So, VS now is 13,250 plus 0 over square root of 3 plus 148.54 angle negative 17.81 3 plus 4 ay 8267.04 8267.04 angle 2.98 degree volts. Okay, so nakuha na natin yung VS tsaka AS. So plot na natin siya sa diagram. Okay, so ang VS is 2.98 na. So banda dito siya. VS. So the angle is 2.98. And then so IS natin negative 17.81. So banda dito siya. IS. So this is 17.81. So kung mapapansin nyo, the angle between them, between VS and IS is the sum of 17.81 plus 2.98. So theta S is 17.81 plus 2.98. So that is ilan? 17.81 plus 2.98. Oops. 20.79. degrees. So the power factor at the sending end is cosine of 20.79 degrees. So the power factor at the sending end is cosine 20.79. 0.935. 0.935. And then sa diagram natin, kita nyo, laging yung IS uh, compared sa BS, no? So, kung laging yung current natin, so the power factor is laging. So, and nakuha natin yung sagot na 0.935 laging. So, thank you for listening and see you on our next weekly board practice solution.